Alright, the following is for general presentation purposes only and does not contain all of train's required safety and other procedures. For any safety or service questions, always contact train. Okay, what we have here is a Seagam 130-ton chiller with scroll compressors, pump package. There's a VFD on the side of the chiller here that controls the operation of the pumps. You got a cross the line start for the compressors. Basically, this is the CH530 Dynaview module. This is the brains of the chiller. It controls pretty much the entire operation. I'll go over a few menu items with you here. The first menu you see is the main menu. That tells you the chiller operation mode. If you look up top, it says stopped. Below that, it'll show the operation for each circuit, circuit 1 and 2. It'll show you the entering and leaving chill water temps, the active chill water temp, and the demand current limit. The next category will be the reports. So you hit the reports button. Up at the top, it'll say evaporator. If you hit that button, evaporator, it'll show you the pump operation, the temperatures, the VFD commands, and so on. If you hit circuit 1, it'll show you refrigerant pressures, refrigerant temperatures, suction line temp, approach. Same thing for circuit 2. So we'll go back, go to the condenser section. Condenser section will show you the refrigerant pressures and temperatures for the condenser, and as well as the current airflow for the machine. So we'll go back again, the compressors, and it'll show you the total chiller operation time. If you hit circuit 1, it'll show you the total starts and hours for each individual compressor. Same with circuit 2 as well. So we'll scroll back one more time. We'll go to historic diagnostics. That'll tell you any prior alarms that this machine has had, as far as pump faults or compressor faults or anything related to chill water temps or pressures. The last category is settings. You hit the settings. That's basically how you configure the machine as far as the design delta, extended pump run times, freeze avoidance, display settings. You can set the clock. If you hit display settings, set the clock, date. You can also lock out individual circuits, individual pumps. Basically that's it. I'm good.
On the control side of the VAV box, we run dual set points for heating and cooling. Heating is 60 to 70, separate adjustment on the thermostat, and cooling is 74 to 78, separate adjustment on the thermostat. At night they do a night setback to 85 for heating and 50 I think for, 50 for heating, I'm sorry, and 85 for cooling. So if they get out of those temperatures at night, they'll do a setback night, so they'll turn on and want to call for the air handler, the chiller, and everything comes on to accommodate that. At the time that it calls for the air handler, the other boxes become occupied just so that you're not trying to overload one box for the air handler. And I don't mean true occupied. In other words, they're going to go there, run their minimum set points and stuff like that to give a place for the air to go. Because if you try to run just one box, we'll be in all kinds of trouble. It also modulates based on flow with the temperature. If you're at 74 degrees, heading down below 74, it's going to modulate between 73 and 75 if your set point is 74, to min to max flow. It'll hit minimum flow at about 73 degrees. It'll hit maximum flow at about 75. It modulates in between 0 to 100%. It multiplies the max number times that percentage, and that's what it starts to put out for air. Trying to think what else for the VAV. Oh, just 2 stages of heating. They're modulated. They're 5-minute staged apart. If the first one comes on, and if after so long the temperature's still too low, it'll bring on the second stage to try to make up for it. We bring them both on just so that we can try to get out of heating as fast as possible, because we don't want to be in heating very long because electric heat is costly. So we don't want to just hover at one stage for an hour. So we'll bring on 2 after 5 minutes usually, and then they just can usually turn themselves back off within usually 5 to 10 minutes because they make their set points. It has flow tubes on it. I mean, that's how it reads the flow. So if at any time you're ever seeing an egregious number and you know you're forcing the damper one way or the other because there's a force method built into the programming where you can actually override it to go open or override it to go closed. At that time you could check and see if the tube come off. You know what I mean, if something happened that way. You know what I mean, because it's a big problem that you can see. If you're reading egregious flow and you know the thing's closed, then you know to look at your tubes. You know what I mean, just for whatever. And like I said, at night it just rolls back. It does have an override in the thermostat. Right there. Inside the thermostat, there's the ability to override. The override lasts for 1 hour. And then after that, what ends up happening, and it sends an override to the air handler. The air handler actually shuts its own override off. It doesn't look for this to go away. The air handler is only going to override for 1 hour. Then it's going to wait for this to send another override back to it if it was necessary. But generally speaking, it shouldn't be. I mean, because once you're only looking to come down 2 degrees, that should happen within an hour. So, and then inside here, I don't know why I didn't take this off. You have, if you hit this button, it lights it up. The first time you go, you see it says cooling at the bottom. This is where you adjust your cooling set point. Okay. If you hit it again, it's heating. That's where you adjust your heating set point. Like I said, it's dual set points, so they're separated. You have to adjust both of them separately. You can't adjust one and expect the other two. It'll trail by 5, but that's all it's going to do. You know what I mean? If you're looking to make it warmer, you can't adjust the cooling to try to make up for it if you're, you know what I mean? Because it's not how it's going to want to see it. You want to adjust the heating, then the cooling will move with it through the program.
All right, if we look above the ceiling here, this is a train VAV. It's got 2 cabinets. Cabinet to the left is the control cabinet and the damper actuator cabinet. And the cabinet to the right has that's the high voltage cabinet that contains the heater contactors, fuses, and disconnects for the VAV. Operation is basically as it gets closer to set point, it'll go to it'll close the actuator down to reduce the airflow for the space. In the heating mode, it'll go 100% open. It's a Train TR200 variable frequency drive. This drive is controlling the air handler motor. Pretty much, there's a set of buttons across the top and a set of buttons across the bottom. The top buttons are how you get your status, quick menu for parameter setups, main menu for more extensive parameter setups, and then of course alarm log up in the top right hand corner, which tells you all the historic alarms that the drive has had. Up and down arrows cycle through the different settings for display. Let's see, the bottom set of buttons, the hand button, that's how you operate the machine through the VFD, where you can set your own desired hertz setting. The next button is the off button, of course, that shuts the air handler down. Button next to it's the auto button. When in auto, the drive is controlled through the BAS system. So BAS takes precedence and sets the VFD speed to its desired setting. The last button is the reset button. If the drive happens to have an alarm or fault and the alarm or fault's cleared, you hit the reset button to actually remove the alarm display off the screen. Lastly is this toggle button down here to the left that powers the drive so you can run the machine through the VFD. The next setting is off. When you turn that off, It'll remove power from the display, and the last setting is the bypass setting. If for some reason the VFD fails, you can put the drive in bypass, and what that will do is run the fan motor at 100% with no control. There will still be safeties, but we will not be getting a speed signal from the BAS system. Alright, this is a Train climate changer air handler. As you see up front here, there's 3 different doors. This door houses the evaporator fan motor and fan blade. Second door is the coil access door for the evaporator coil. The last door is the filter box for this air handler. This particular air handler is a direct drive with a plenum style fan. Any questions that you have for maintenance, I suggest you refer to the IOM for the air handler. As far as maintenance procedure on the motors or filter change or coil cleanings.
This is one of the VFD air handlers, and it's controlled based off of static pressure. It does have a static pressure reset, so don't be alarmed if you come in and this is ramped way down and you're going, why is it ramped down? It's because what ends up happening per sequence is if all the boxes are below 65% open, I will actually increment the static pressure down by 1/10 of an inch at a time, every 15 minutes until the boxes float between 65 and 76%. Once a box goes above 76%, then I'm going to start incrementing it up to 1/10 at a time. Every day it resets back to the nominal, and that'll be a final number that I will get from TAB. You know what I mean? What they do, their total flow and worst case box. Then that'll be my starting point every day. I'll go to here, start my sequences. The fan will operate to that speed until 15 minutes goes by and it says, okay, all my boxes are below 65%. I can start incrementing down again. It also controls the chill water valve off of temperature. Starts off at 55 degrees off coil temp with the ability to go from 54 to 58 for a reset. And it does have a temperature reset that's based off of cooling in the space. Max cooling in the space is below 40%, but I'm going to increment it up a half a degree at a time. That's all adjustable by y'all in the end. I mean, if you want to slow it down, speed it up, you just change it from 0.5 to 0.1, whatever. You know what I mean? So that but it's every 15 minutes, and that's adjustable as well. It's done in seconds, so keep that in mind. You'll see a number of 7,200. Whoa, that's actually 7,200 seconds, which is every 15 minutes. Okay, and it'll adjust those up and down that way. And it looks at if it gets above 70% calling for cooling, then it's going to start incrementing up. The reason we choose these numbers is it's got the 74 degrees runs between 73 and 75 for its percentage. So when we're below 74, we're actually below set point, so what it does allow us to increment up.
So is it looking at the cooling coil
no,
or supply? Supply air.
Right now it's looking at cooling coil, but I'm probably going to change it to supply. Because the reason I say that is the supply is actually an averaging sensor, so it'll be a more accurate read. Okay. That's just a stick probe, so you know what I mean, and it's only so far in, so it's only reading so much of the airflow. This reads across, it makes across the duct, so it reads more of the flow. Okay. So I'm probably actually going to change that today to read off of this flow.
And where's that mounted at? Is that averaging sensor?
It mounts here, but it goes in this way because it's an actual, it's like a cable. It runs in and they run it across the opening here.
Okay, so it's like at the bottom of the opening like this.
Right, and it's got 4 sensors in it that average the temperature.
Right. Okay.
So, since you brought that up, if it ever fails, you'll know. Because you'll see this one saying it's like 54 degrees, 55 degrees, whatever, close to its set point. And then you'll see this one saying 85. So one sensor went out and it's still using that 0, or it might fail the other way. I think it fails the other way. So we're using that 140 to average in with the other one saying 54. So now your temperature jumps up to 80 degrees, and you know it's not 80 degrees. That tells you the sensor's failed. Just for troubleshooting purposes on your end. So it does do a static pressure reset. It does a temperature reset based on the boxes out there, max cooling call, not temperature. So remember that. Don't go, well, the temperature's 78 degrees. Why isn't it resetting up? Down. It's because the set point may be 78 degrees. You know what I mean? So we have to do it off of cooling required for the boxes. And then the static pressure based off of box position. The return dampers and the outside air damper are attached to a, and of course this is not the room for this because it's in the ceiling out there in the hallway, but there's a transducer for reading the outside airflow. So based on the outside airflow set point, that outside air damper will open. If it gets to 100%, it still hasn't made it, then it's going to start to back off the returns. The returns can only close to 20%. They will not go below 20% because you never want to fully close the return on a unit this big, because that outside air is not meant to supply full stack by itself. So so don't be alarmed if it's not fully closed. I'm still shy a little bit. I mean, if the static pressure reset came down or whatever, then it'll start to look at that differently again. It'll start to adjust for that. But what I'm saying is, so don't be alarmed at that being at 20% and that one being 100% open with the speed being low. Because that's just saying I need to have that much of my return closed off to force enough air through that outside air to make my set point. So this one doesn't have a CO2 on it. The only one that has a CO2 on it is the cafeteria. For monitoring CO2 in the cafeteria, which is the cafeteria unit looks like this one, but operates differently. So it operates like a VFD box.
So the CO2, is that just for monitoring, or is there a sequence for the CO2?
As far as I know, that's just for monitoring. You could use a sequence for it with the outside air. But you would have to. I think the reason they don't do that is because the outside air is already probably at its pretty close to minimum. But the exhaust fans, because you can't pull. For your outside air, you have to bring in 10% more than what you're going to pull out with exhaust. If you do it otherwise, then the problem's going to be, you're going to end up with a negative building, which is a bad thing for you. Every time you open the door, you're bringing in unconditioned air. Right. Oh, these switches here are your high-low cutouts. If the negative pressure on the side, on the filter side of the duct gets too low, it's going to trip the unit. Now this is just like a fire alarm trip. It is a manual reset. These buttons have to be manually pushed. You will have to come here for that. That is also to, if it happens over and over, it will make you want to look into why. You know what I mean?
When you guys wired them, is that a dry set of contacts? Or is that
it is.
24 on it?
It's got 24 on it, but it's dry. And how it works is it takes one leg of the 24 volts that comes over to this relay over here, and it goes through the dry contacts. Okay? If either one of these dry contacts breaks, it breaks this relay, which breaks the safety circuit in here, which shuts the drive off.
Right, and the 24 is fed from?
It's fed from a transformer underneath the controller over there.
Right.
So that, but like I said, so you'll come in here and you'll see the slab like usually an alarm 60, I believe it is, which says it's a loss of contact closure. The safety contact is open or something along that lines. That's either these, and if these are not the problem, then it's a fire alarm issue. That's the only thing that does that safety circuit. You know what I mean? And they are the only ones that will not allow you to put this in bypass. You know what I mean? So if your fire alarm's having an issue and you want to put it in bypass, you're going to have to, you're going to have to either take the wires off or try to find a way to override it at the panel to be able to put this thing back online, because it will hold it out. So, and why I mentioned the other one, it looks like this, but it operates like a VAV. Based on temperature, it ramps it up and down. And it also uses that same ramp up and down for heating, which will have a minimum, so it won't go so low, but it will allow it to go higher and lower based on temperature. And it has, I don't think there's anything else special. They have the electric duct heaters, which these do not have. Because it's a VAV system, the VAVs do all the heating. This has no heating involved. Okay. Now the set points allow us to go between 54 and 58. When this thing goes into dehum, because there's a dehum sensor out here in the hall, when it sees the humidity gets above, I believe it's 60%, it's going to put the unit in dehumidification mode, which at that time this valve is going to open 100%, and it's going to allow the temperature of this coil to drop as low as it needs to.
Now there's a plus or minus differential for that humidity.
Right, so once it drops by -5 to the set point, it will then kick it back out of dehum mode and go back to working the way it was supposed to. It'll go back to its nominal set point and start resetting up or down based on box positions and temperatures at that point. So your static will do the same. So that way, I mean, you're drying out your building, and the heaters out there will maintain space temperature. That's all they do. The heaters just come on to maintain space temperature. They're not part of a sequence for dehumidification.
Okay.
So I'm just want to throw that out there. So do what do they do currently? They just work the way they're supposed to work.
Right.
Whatever their heating set point is, they're going to maintain.
How you doing there? My name is George. I'm working for Wellthrough Services. I'm here to explain to you how plasma ionization bars work and maintenance, basically. The first thing that we do, any service that we do to units, either ionization bars, filters, anything, we always turn the unit off by flipping the disconnect here at the power supply. And we open the return box. And take some filters out because ionization bars is always located between filters and evaporator coil. I'm here to explain to you how the plasma bars operate. Basically, it's a needle bar that is located between AC filters and evaporator coil. What this does is positive and negative ion reduce the airborne in the air, basically killing bacteria, mold, except for Ebola. That's the only thing but this is basically clean the air and the space. How does that work? The plasma air, that's a power part over here. They create ions, positive and negative ions. It's free maintenance. The only always we recommend every time you guys change filters or clean the coil, turn the bar from here. That's why we locate the power pad inside the return air. That way you always know when it's on or when it's off. When this light's on, it's the ion is basically creating ions to clean the air. Free maintenance. The only that you guys can do, I said, every 6 months or every time you clean the coil, turn off over here and then vacuum the needles. It's needles all the way the bar. That's the only maintenance required. This equipment basically never fail. I never seen one damage in the last 10 years, which is they're really good equipment. Free maintenance, no parts needed, and that's basically what it is.
My name is Chris Hvac with Hvac. We're here to do the water treatment testing. We're going to test for nitrite today. So you guys come down here, you got this valve open. This is the crack. Let it flush for a few seconds. You don't need a lot. You're going to take your sample vial. You'll have a sample vial. You'll have 2 tests. Rinse it 3 times. Then you're going to look for the 5 mil line. Fill it right up to the 5 mil line. You put 4 drops of your indicator. And then your solution here, each drop is worth 40 ppm. So you'll count as you go. Nice and clear blue, that's your treatment. So we had 20 drops at 40 ppm, we have 800 as our level of nitrite. That's exactly where we want to be. Alright? That's the testing procedure. We'll have sock filters. So what you do, come here, you'll isolate off the supply at the return. Open this up just to let a little bit of the pressure out. Take the cap off. Hold it, just tap it until it releases. You don't want to hit it because you'll actually break a prong off. Or it'll start coming out, you can close it up at that point. There's a little get below the hole, that means the water's going to go through the filter. All right? At that point, you can open up either valve, but I open up the bottom one because that'll bring the water up in a smoother way instead of spraying yourself with it. Try to get it up here. You don't want too much oxygen introduced to the system. Make sure your seal right here is seated nice. Sometimes it'll start to pop out. You just slide it back in. You can get it with a screwdriver. Same thing on the way back. Spin it until you can't tighten it. Hold it. You'll see it work. Put that back on. Make sure your valve is closed in case you left it open during the process. Open up your supply. Open up your turn and you're done. That's water treatment. Good?
How often do you check this off?
I check this quarterly. The filters are supposed to be changed monthly. There's 12 filters and it's covered for the first year. So I changed the filter today. That'll be, I already changed it 2 weeks ago, but I changed it today. It'll have to be changed next month. Each month you just, same thing. Close it, change it, you're done. Anything else?
So where's the beer?
Alright, this is a train mini split. This particular model has a display. The red power emblem up there on the cover indicates that the machine is not operational right now. Pretty easy. We've got this controller that controls the entire operation of the machine. So if we hit the power button, we'll get the display up there stating the desired room set point temperature. Back to the controller. On this controller there's a mode button. The mode button is what you press to cycle through the different settings as far as dehumidification, cooling, heating, and so on. The next button up here is the fan button. That's how you set the manual fan speed. There's multiple speeds, slow, medium, high, and high. Next set of buttons down here is the temperature adjustment buttons. So if you would like the room to be cooler, you simply press the down button in order to change the temperature to a cooler setting. The buttons off to the left are for the vane operation. You can manually set those to different positions as well. It has a sleep timer, the clock button, quiet fan setting, and the light as well.